everything about the Starchild Skull's case comes down to its DNA. DNA is a molecule of life. This is a cell, and inside the nucleus are the chromosomes. Chromosomes come down and they unravel. You unravel the chromosomes and you're looking at the DNA. And the DNA is made up of the bases. We're going to see that in a minute. And what the DNA does is the good, not the junk, the stuff that works, makes proteins. What you have to understand is about 97% of all of this, of everything in here, 97% is junk or non-coding or whatever you want to call it. It doesn't make the proteins. About 3% of this runs us. The rest of it is like, what is it there for? We're still trying to figure that out. It could be spirit, could be a number of things. But junk is not dealt with at the scientific level because it's not quantifiable. Okay, they can't quantify it. So anyway, this, we need to all understand this, and we're just getting started. Okay, next slide. We'll see a different look at it. What we were looking at is made up, the base pairs are only 4. There are only 4 base pairs. Thymine, adenine, guanine, and cytosine. And that's it. And these two go together, thymine, adenine, and guanine, cytosine go together, and they don't mix. It's these two, and they make these steps, the base pairs. These are the base pairs. These are the nucleotides. These are the nucleotides. These are the base pairs that the 2 nucleotides come together and make. So that term is used kind of interchangeably. When you say a nucleotide, you know, if you know the nucleotide, you know what its partner is automatically. So all you need is the nucleotide, and you know it's a base pair because you know what the other side of it is going to be. So you can strip them apart like this and get to nucleotides, and you know what goes on the other side of it. So nucleotide base pairs, don't be confused by that. It's essentially the same thing. We tend to use base pairs, but if you see nucleotides, not a problem. So you have all of this, and all 3 billion of them are wound up like a wad of rubber bands in the nucleus of the cells that we saw just a minute ago. They're just like rubber bands, just wadded up. And that's it. Very, very tightly packed. Next slide. All right, each human cell except red blood cells has nuclear DNA and mitochondrial DNA. You need to understand this. Mitochondrial DNA, this is the cells in our body, all of our cells except our red blood cells, have a nucleus. Nuclear DNA is found in the cell nucleus and contains genetic material from both parents. Mom and dad make the whole genome. Mom supplies her 23 chromosomes, dad supplies his 23 chromosomes, and you get 46 total. That is, each cell nucleus has 3+ billion. Keep this in mind, 3+ billion nuclear DNA base pairs. 3+ billion. Now, mitochondrial DNA, that only comes down from your mother. Now, the mitochondria float outside the nucleus, but in the cell cytoplasm, like raisins in pudding or something like that. But there can be hundreds to thousands of them, depending on which cell we're talking about here. Now, that comes, mitochondrial DNA is found in the cell mitochondria. Now, these are the energy points. These are the power plants. These make the proteins and do, this does the work. This just sits and is sort of king of the hill, but this does the work. It contains genetic material only from the mother. Why? Because an egg has plenty of room. You've all seen films of the little bitty sperm coming and hitting the egg. So the egg carries the mitochondria. The sperm is nothing but just the DNA package and a tail. The egg has her DNA package and all the mitochondria. So it only comes down from the mother. So the mother, the grandmother, the great-grandmother, the great-great-grandmother, right on back, they all have the same mitochondrial DNA. I have the same mitochondrial DNA. You have the same mitochondrial DNA of your mother, your grandmother, your great-grandmother, going on back with very little change. Okay? And so that's why all human mitochondria contains 16,569 base pairs. Sometimes one up, sometimes one down, sometimes 70 or 68, but the number we nearly always share is 16,569, precisely, all the time, and each cell holds thousands. Now the difference is, this is swapped around from the nuclear DNA. The nuclear DNA is 97% junk, 3% working, right? This is 97% working, 3% junk. Wow. So this doesn't change much. It doesn't allow much room. You can have a lot of mutations in here because the odds are it's going to hit in the junk and isn't going to have a real major impact on the functioning of the body. But here, you get a mutation or a change or a difference here, and you hit out in that 97% that's working, you're going to have problems. And if you have faulty mitochondrial DNA, don't have kids because they aren't going to make it. That's where if they find women who have faulty DNA, they have 1 or 2 or 3 miscarriages and they figure it out, they start taking their genetic package out, but they'll take the egg of a woman who doesn't have the mitochondrial DNA, so their kids will be born with the genetic package of mom and the genetic package of dad, but the mitochondrial DNA of a 3rd woman. But you can have your own children that way. A couple can have their own children. Very cool how this works. But anyway, all right, next slide. This is early DNA testing used primers, 20 to 30 base pairs long, below is an early array in a gel sheet. Now this is important to understand because you have to understand the story of the Starchild's early DNA testing. Next slide. The first testing was done at the University of British Columbia. I made a mistake. We couldn't, there were only 6 labs in the world that could do nuclear DNA at that time. None of them would touch the Starchild. And so there was this lab here. It was a new lab. It was a dental forensic lab, totally incapable of dealing with ancient DNA. And the guy said, well, I'll just try to find out if you have live DNA there. Because sometimes a skeleton bones can be so degraded that they just can't recover anything, but either mitochondrial or nuclear DNA. He says, I can't recover mitochondrial, but I can recover nuclear, and if I find anything nuclear, you'll at least know it's worth trying to gather the money and keep going. So I said, okay, great, next slide. So what he came up with was after 2 times where they contaminated it, and a 3rd time, they came up with this result. Now by then, a guy on the team, one of the kids there, again, this is a university, this is a main geneticist and kids and students doing the work. And they're just screwing it up. They're just contaminating it every time. The first 2 times, and they did it again this time too. But by then, the rest of the university had heard what they were doing, that they were working on maybe an alien skull, and the other professors dropped down on them, and now they were just trying to get rid of us. Get us off the camp, get us out of the deal. So he said, after the customary number of PCR cycles, 28, there was a very weak 200 picograms gender profile from the second bone sample taken from the child's mastoid process. Now, normally 1,000 picograms were the usual minimum threshold at which you could tell anything about what you had. And the guy says, we only got 200 picograms, but we know that it's a result of an XY chromosome, which tells us 2 things: the child was male and it was human, right? This is a totally BS report and a totally BS answer. But the problem was in late 99 that went out as the official answer, and it was exactly the answer that mainstream science wanted. Human male. End of story, end of tape. We don't have to worry about the Starchild anymore. And so to this day, you will read that this is the answer, that it was already proved to be human, even though this was in 99 when they were using primers of 20 to 30 base pairs long, and it was easy to make mistakes, and these guys didn't even get it. They didn't even get it because why do we know? The next slide. But now this, you have to understand, this caused a disaster to our team. We couldn't get a hearing anywhere. The Bowl lab report equaled 3 years of dead time. 3 years from November of 99 to November of 2002. When, by that time, I had spent so much time and energy and effort trying to resuscitate it. I had gone horribly into debt, about $50,000, and I was going to have to go bankrupt. So my girlfriend at the time says, this is killing you. This is killing you. You have got to stop this. You've got to just give it up. So I sent out the word that I was, I just couldn't go anymore. I had done my best, but somebody else was going to have to take over and go from here. And then, next slide, Miss Belinda McKenzie of raises the dead. Raises the dead. She contacted me, first contact, what do you need? I don't know what I need. I haven't even given it any thought for so long. Find out what you need and let me know. And so we did, and we found out, and we told her, and well, she did her due diligence. It took a few weeks, but finally a check arrived, and we were back in business. So Belinda is one of the key and major players in this whole thing. Without her, I wouldn't be here today, and that's the truth. So again. All right, next slide. Now, so what she paid for was a real DNA test from real geneticists who were capable of recovering ancient DNA. Now, what do I mean by ancient DNA? Older than 50 years. That lab in Vancouver, they only dealt with fresh DNA. They couldn't deal with very old DNA, much less 900 years old. Over 50 years, there's a huge amount of degradation, and there's a huge amount of contamination from the bacteria of death that we were talking about. Right? So this is not an easy thing to do, but these guys could do it because they had worked on the Kennewick Man. Anybody heard of the Kennewick Man? The Kennewick Man. Yeah. This was a skeleton that was found in Washington State on Indian territory, and it looked clearly like a normal European. And the Indians went bazookas because they have these gambling concessions in the States, because they get all these special privileges because they're supposedly the first people to settle America, and so they work really, really hard anytime something comes up to indicate that somebody was there before they were there. And the Kennewick Man was like 9,000 years old and looked like a European, so that wasn't going to happen. So they made the Clinton administration cement the whole thing over, and the Kennewick Man. And it became this big legal case, and they eventually, it took like 6 years to be able to study it. Well, these guys studied it, and what they found was that the Kennewick Man was exposed on a riverbank. That's how it was found, and the water would wash in and cover it, and then the water would go out, and the sun would bake it, and so it was absolutely sterile. There wasn't any nuclear DNA, there wasn't any mitochondrial DNA, there was just nothing to recover from. So at that time, later they were able, as the refinements got better, they were able to tell its date and stuff like that. But at the time, that's where they were. But these guys did a great job, and here's what they did. Next slide. Using, again, primers. Keep in mind, 20 to 30 base pairs long. 20 to 30 base pairs long, short-length base pairs. They recovered the human's mitochondrial DNA, and she was from haplogroup A, and they found mitochondrial DNA for the Starchild from haplogroup C. And that's what that means. They also found, next slide, that in 6 attempts at finding the nuclear DNA, they couldn't do it. They were 10 times, 100 times better than the lab in Canada, and they couldn't do it in 6 attempts. They could not find nuclear DNA. So that proved right here that what they had said in '99 from Vancouver was wrong, just was wrong. Should have been thrown out right there. Again, you can still read on the internet that the '99 test was better than this test. And this test has turned out to be wrong, because those primers are so short, 20, 30 base pairs long, and in 3 billion base pairs, it's not too hard to find pieces 20, 30 long that match up. But when you get out to 2 and 3 and 400 and 500 long, it's a different story, as we'll see with the new geneticists. Next slide. So, but out of trace genetics, those two guys, the result was that the Starchild Skull was a human-alien hybrid, and some of you might remember who have been here when I talked about it as a human-alien hybrid. You might have seen that very same slide. We believe that up from their test in 203 right up until 210, we believed that was the result. Next slide.